Okay, guys, this right here is our review for your last test for this semester. And this, I'm gonna walk you guys through this. I'm gonna explain how to do this. And what we want to do is use this to help you study for the test, which is going to be on Thursday and Friday. All right, and so this is going to be very, very similar. So once I go through this, this will give you all of the tools that you're going to need to go into Schoology and complete the test, that the actual quiz that I set up in there, that's multiple choice or drop down menus and so on and so forth. So the question is talking about when measuring the wind speed of a hurricane or similar storm, meteorologists don't want to get hit by flying debris. They use a measure available to them in the comfort of their TV studio. So luckily for meteorologists, the barometric pressure is linearly related to the wind speed. Okay, so what that means is it's a line. So what we're talking about, I just want a big overarching understanding of everything that we're doing is talking about a line. I can't overestimate that, right? So we're talking about linear relationships, and what we know about linear relationships, we just have to put that into use. In linear relationships, we are going to have two variables. So if we look at this, we say barometric pressure, that's going to be one variable, and wind speed, that's going to be the other variable. Okay? So if we have two variables, those are the things that we set up, right? All of that other stuff, all of that other information is really not necessary for us to solve the problem. So suppose scientists compared the wind speeds and barometric pressure readings of two severe storms over the Atlantic Ocean. Okay? For one of the storms, the barometric pressure was 1,000 MB or millibars, and the maximum wind speed was 100 kmh, which is kilometers per hour. Okay, so that is one storm, right? So one of the storms is this. And now we're going to read about the second storm, okay? And I'll highlight this. I'll say, okay, here's one of the storms, and there's one variable, and there's the other variable for that storm. All right? So it says the second had a barometric pressure of 960 MB and maximum wind speeds of 80 kilometers per hour. All right, so the second storm that we're talking about here is going to give us these numbers, right? All right, so here, there's the barometric pressure, and the wind speed is right here. Okay? All right, so here's what it says. It says, develop a rule that you could use to predict the wind speed given any barometric pressure. So back to the basics, wind speed and barometric pressure. Okay? So just think about it. We got wind speed, we got barometric pressure. So let's label some things, and let's talk about what we're going to define here. And let's say that X is going to be our barometric pressure, all right, and that's going to be measured in MB, right, millibars. And let's say Y is going to be the wind speed. The wind speed is what we want to get out of this. That's what we call our dependent variable. It depends on the barometric pressure. So if we plug in a certain amount of barometric pressure, then we're going to get a certain wind speed. Okay, so wind speed, and that's going to be measured in kilometers per hour. Okay, so over here on the right, I'm going to go ahead and say X and y. I'm going to create a little table here, and what they've given us are they've given us two storms. So two storms are going to represent basically 2 points on a graph. Okay, so how do we write points on a graph? Well, we go x comma y, right? So x comma y. Well, for the first storm, our x value is going to be millibars, right? So that's going to be the barometric pressure. So the first storm, barometric pressure was 1,000 millibars. Okay, and the wind speed was 100. Okay. The second storm is going to have a barometric pressure of 960 millibars. Okay, right, and it's going to have a wind speed of 180 kilometers per hour. So what we're tasked to do here is develop a rule, right? So give me a rule that you could use to predict the wind speed and given any barometric pressure. Okay? All right, so we know there's two things that we need to know when we're talking about coming up with a rule or understanding linear equations. And the first thing is m. So we need to know m, which is my slope. All right, and we know that m equals the change in the y values. We know two y values up there over the change in the x values. Okay, so what I'm going to do is I'm going to look at these two things and I'm just going to replace those. Okay, I'm going to erase this right here so we don't get too confused here. But let's go back and let's say the slope is going to be the change in the y values. So how did I get from here to here? What did I do to get from 100 to 80? Well, I added 80. Okay, so it's going to be plus 80. That's my change. That's the change in the y values. All right, and so what did I do to get from here to here? All right, well, I subtracted 40, right? To get from 1,000 to drop it down to 960, what I did was subtracted 40. Okay? So I'm going to say minus 40. Now, we don't say keep it at 80 over 40 because what we want to do is we want to simplify. We want to make things simple. Okay? So as simple as we can possibly make it, 80 divided by 40 is going to be 2. Right? How many times will 40 go into 80? Go in the 2 times. 2 times 40 equals 80, so my slope is going to be negative 2. Okay? Now, we know from what we did earlier, we talked about in lesson 1.12 and 1.13, we know this formula, okay, and this formula is going to be the point slope formula. Okay, and the point slope formula says this. It says y equals m times x minus x1 plus y1. All right? Well, guess what? We just need point slope formula is for when we have a slope and we have a point. All we need is a slope and a point. Okay, so if we have a slope and a point, we can go ahead and put it into this formula. All right, so what I'm going to do is I'm going to use this right here. I'm going to use the point 1,000, comma, 100 as my point, and I'm going to use my m as -2, right? So just like we practiced a little bit of those, all we have to do here now is just go up here and we're going to substitute in for m, we're going to put in -2. Okay, so this right here is x1, this right here is y1. Okay, so x1 is going to go right here, and y1 is going to go right here. Okay, all right, so what am I going to do? I'm going to go back in, I'm just going to plug them in. Okay, I'm going to erase these. Right here. Right. And I'm going to plug in what I know. So that -2, that goes right here. Okay? The x1 goes right here. Okay? And the y1 goes right there. Okay? And that's it. That's my formula for this. Okay? Erase that, make it look more like a y. Okay? Formula is y equals -2 times the quantity x minus 1,000 plus 100. All right. So now we're going to move on. All right, and we're going to be asked some more questions here. All right. It says, use your rule to predict the wind speed of a hurricane with a barometric pressure of 980 MB, millibars. All right, so 980 MB, if we go back up to this right here, we look over there, well, the millibars are the x values. Okay, so if I look over here, right, the millibars that's a barometric pressure reading, right, and it's measured in millibars, right? We don't want to get too confused about, millibars and kilometers per hour and all of that stuff. Just understand that that's the number that we're looking for. That's my x value, all right? So what I'm going to do is I'm going to say, all right, well, I write down what I know, okay? I know that x is going to be 980 millibars, right? So x is 980, right? So it says if it tells me to use the rule, I know that I'm going to have to plug something in or do something up here to figure out the answer. So what it tells me is go ahead and rewrite this as -2 times x minus 1,000 plus 100. Okay, well, guess what? Right here, I'm going to go up there and I'm just going to put 980 in for x. Okay? So I'll go ahead and do that. All right, 980 right here. To rewrite this a little bit to fit it in. Minus 1,000. Okay? And now I can go ahead and get to work on solving this. Okay? If you notice, all I have are numbers. I have a y on the left side. It's solved for y. What is y? Y is right up here. It's the wind speed. So if I solve it for y, I'm going to get the wind speed, and that's going to be in kilometers per hour. Right? So when I do this, I can't multiply the -2 times what's in parentheses here until I do what's in parentheses. So it's going to be -2. Well, 980 minus 1,000 is, when the signs are different, I subtract them and keep the sign of the bigger number. The bigger number is 1,000. So my answer here would be 20. Inside the parentheses, that's going to be 20, negative 20. Okay? Then I have 100. Okay, so when I multiply negative 2 times negative 20, a negative times a negative is a positive. So negative 2 times 20, 2 times 20 gives me 40. Okay? And I can continue to drop down this y and continue to rewrite it just one more step at a time. And then I have to add the 100 to it. So I add the 100 to it, and I get 140. Okay? And what does 140 mean? It's 140 kilometers per hour. Okay, so there's my answer. But what it also asks me for, it says using what you know about linearity. Okay, it's all about lines, right? So explain why your prediction is reasonable. So we got to explain why your prediction is reasonable, right? So in the explanation, okay, I just have to notice a few things, pick some things out that I would notice, all right? So going up to the top right here, well, if it's 140, okay, if I went up to the top, I wrote these things down, my barometric pressure is 980. That falls right between 1000 and 960, right? And exactly halfway between, right? And if my wind speed is 140, okay, doesn't that fall halfway between? Yeah, it sure does. Okay, so 980 falls right between 1000 and 960, and 140 falls right between 100 and 180. Okay, so that gives me a little bit to think about, and I can write an explanation by doing this. Okay, so yes, is it reasonable? All right. All right, I'll say it is reasonable because it fits between the two other points. Okay? And you could say more specifically halfway between the two other points, but just to save some space here, that's good enough. Okay? All right, so that's part of my answer just as the answer is. All right? So now you have we have A and B complete. Now we want to move on. All right? So the next one, it says to interpret the intercept for wind speed in this context, i.e. as it pertains to the weather. Okay, what is the intercept as it pertains to the weather? Well, what we have to do first is find out what the intercept is. Okay, so we know that the y-intercept is B, okay, and it's at a point where x, if that's an ordered pair, there's x, so is 0, and whatever the y-coordinate is where x is 0, that's going to be my y-intercept, okay? So if I can plug in x to be 0 up there into my equation, I can figure out what the b value is going to be. All right? So if I plug it back in, if I go up and I use this equation one more time here, I'm going to go y equals -2 times not, and this right here would be the x value. Okay, we said x minus 1,000 plus 100. Okay, well instead of x, I'm going to plug in 0. Okay, because this right here, the y-intercept, is where x equals 0. So think about it. If you're on a graph, the vertical axis is where x equals 0, right? You're not going left nor right. Okay? So if I plug in 0 there, take that out, and I go ahead and plug in 0 here. I'm going to go ahead and erase this, and then I'm going to solve. Once again, all we have are numbers on the right hand side. Okay, so what's my y-intercept going to be? I have to do this first. 0 minus 1,000 is just -1,000. So I write it down as -2 times -1,000. Okay, and say plus 100. -2 times -1,000, a negative times a negative is a positive. So I get positive 2,000, but I have to add that 100 to it. Okay? Continue to write down those y's. And remember, each step going down is just narrowing it down. It's getting a little bit more simplified. So 2,000 plus 100 is 2,100. What does that mean? Well, if you remember when we went back up here, y equals 2,100. What is y? Y is our wind speed. Okay? So our wind speed is 2,100 kilometers per hour. All right? So there's our answer. Okay? Now it says to interpret the intercept in terms of wind speed. Okay? So we're going to say for every increase of 1, for every increase of 1 millibar, okay, of barometric pressure, there is a decrease of 2, okay, minus, okay, I'm sorry, I'm not explaining the intercept, I'm explaining the slope. There's a decrease of 2. I'm just going to go ahead and explain that, and I'm going to put that in there. Put that in right down here because that's my next question. There's a decrease of 2 kilometers per hour of wind speed. Okay. So that is not the question that was just asked right there, but this goes right here. Okay? But let me explain let me interpret the intercept for you. And so the intercept, remember, intercept is starting point. Okay, the intercept is a starting point. Okay, so how do I interpret the intercept? It says that the starting point the starting point is when there is 0 millibars of barometric pressure and the wind speed is 2,100 kilometers per hour. Okay? So I'm going to circle this and I'm going to draw a line, okay? So that is interpreting this right here, right? Just so you know, because I did it backwards. My fault right here. Right, and so this one right here is the answer to this question. All right, so if they ask you about intercept, the intercept is a starting point. Okay, that's where you start from. Okay, and the starting point is where the x value is 0. In our case right here, the x value is barometric pressure. Right, so at 0 millibars of barometric pressure, the wind speed is 2,100 kilometers per hour. Now here's the problem. 2,100 kilometers per hour is very, very, very fast. Okay, a race car, a drag race car, a jet drag. I went to Vandermeer Speedway one time, and a jet drag was clocked at 300. It got to 300 miles an hour. So I don't know what that would be in kilometers per hour. It'd be a little bit more, but 2,100 kilometers per hour is way too fast. Okay, so that's way too fast to be realistic. So it's unrealistic here. All right, and how do I know that it's unrealistic? That right there is not realistic. How do I know? Well, look at it. You can go into the internet and you can say you just research these things, right? So that's what's good about computers is we can research it and we can say that if we go to the internet, we could say what's the fastest wind speed ever recorded. Well, I looked that up and the fastest wind speed ever recorded was somewhere around 400 kilometers per hour. They can't record hurricanes, or they can't record tornadoes because, I don't know, it's hard to record a tornado, but I think that's going to be a little bit faster than a hurricane maybe. But the fastest wind speed ever recorded was 400 kilometers per hour. So 2,100 kilometers per hour is that's just not realistic, right? But it is useful at certain points, right? So the barometric pressure, I'm not sure about the barometric pressure, but a barometric pressure of 0, I don't know if that's possible. You'd have to look that up. You'd have to see if that's possible, right? But for the most part, okay, that's what they use to figure things out. If there's if we say the higher the barometric pressure, the lower the wind speed. Okay, higher the barometric pressure, the lower the wind speed. All right. Guys, that's it. That's all we have for this one. Right? If you have any questions, just let me know. There's a lot of stuff. I'm going to scroll back up here and walk you through it. Just make sure that you put your name, date, and period on it. Okay, and you can turn it in. By taking a picture of it, or just go ahead and submitting the digital format of it. Now, what I'm most interested in is not necessarily that you are turning this in. I want you to use this, take this to Schoology. Make sure that you have this. You've written it all down. Go to Schoology, and then there's a little quiz that asks all of those questions in five questions. It asks all of those questions that I asked below, and it asks you to answer those, and it gives you a drop down menu, and all you have to do is just fill them in. All right. So if you do that, then you're gonna, and you've answered them all correctly. That's a 100-point assignment right there for you, and you're done. All right, guys. Thanks for watching.